thank you all for coming, and thanks to the organizers for the opportunity to moderate this panel. And so let me introduce briefly the panelists of this session. So Anastasia Marchenkova from Blacksimo Corp. Anastasia has been a quantum researcher at Georgia Tech Quantum Optics and Quantum Telecommunications Lab, the University of Maryland Joint Quantum Institute, and she's the founder of Course Shark and Jokudo, alumni of Flashpoint Startup Incubator, and early employee at Rigetti Quantum Computing, and currently working at Blacksimo on superconducting quantum accelerators, and is an affiliate at Lawrence Berkeley National Lab. Hi, Anastasia. Travis Scholten from IBM Quantum. Travis Scholten is an applications researcher at IBM Quantum, where he works on collaborations with the IBM Quantum Network. He received his PhD in quantum characterization, validation, and verification from University of New Mexico in 2018, and a Bachelor of Science in Physics from Caltech in 2012. He's been advising the Unitary Fund grant program since its inception in 2018. Hi, Travis. And so Sukin Al-Nassim at Harvard and Zapata, actually transitioning from Harvard to Zapata. She's a research scientist on the quantum AI team at Zapata Computing. She will receive her PhD in chemical physics from Harvard University in May 2021, where her thesis was on algorithm development for near-term quantum computers. Anna is also part of the advisory board at the Unitary Fund grant program. Hi, Anna. And Davide Venturelli from USRA and NASA is Associate Director of Quantum Computing at the University Space Research Association, USRA, and Senior Scientist at NASA Quantum AI Lab, a member since its foundation in 2012, and is co-PI awardee of multiple NSF and DARPA programs on optimization with quantum and quantum-inspired methods, and is co-leader of Ecosystem Task Force of Fermilab's Superconducting Quantum Materials and Systems Center, SQMS. Hi, Davide. And finally, William Zhang from Goldman Sachs Unitary Fund. He leads the quantum research group at Goldman Sachs. He's the founder and president of Unitary Fund, and he previously worked at Rigetti Computing, where he led the creation of Rigetti Quantum Cloud Services. And I hope that's correct, Will. And hi, Will.
Close enough. Good to see everybody. Thank you, Nathan.
So to all the attendees, please feel free to write your questions as they come up in this little box on the bottom right on Zoom, this Q&A. And I will start with some. And first, I'd like to ask Anna, since she's right now starting a new job at Zapata Computing after an internship, I wanted to ask her, what is the best way to secure an internship? And yes, and if you could develop on that.
Yeah, that's a great question. I don't know of the best way, but I think first of all, it highly depends on the specific company, the specific team that you are kind of applying to be an intern for, and of course the projects that they have in mind. But I think from the standpoint of the applicant, of course, having experiences or skill sets that are relevant to the intern position that you want is important. So for example, I've only really applied for and worked on research internship positions. So in order to prepare for that, of course, I made sure I had garnered enough experience in doing some type of scientific research in quantum computing or some adjacent fields. Right, for example, if you're applying for a quantum software internship, maybe it's a good idea to have some experience under your belt so that you can convince essentially your potential employers that you're well prepared for the role at that company. So if anyone else has anything to add.
I can add that it's quite important, at least, since we have an internship program and we receive hundreds of applicants, it's quite important to do a research indeed on the target. Like, you know, if you're pitching yourself as your first experience, and you don't have a lot to show because you're a young student and you don't have a lot of papers or things, like, at least what you can do, you can study the papers of the person that you're selling, you know, your this opportunity to, and then based on that, elaborate on things that show that you did some work. So that's maybe.
And actually, there is a question that is related to this development. Soham Pai, or Pal, sorry, is asking, how can you get the experience without an internship?
Yeah, I can take that maybe. So one of the things that's when I was listening to Nathan read like my bio and others, I feel like I've been around this space I'm getting older. It's been around for a little longer, but something that's new now is that it's more accessible than ever. So when I was doing my PhD in quantum stuff, you know, the only way to get exposed to research was to already be in an academic group, to already be in a group, go to the seminars, you know, attend that somehow. And it's different today. You can view the same seminars we're all viewing as professionals on YouTube. You have tutorials and open source software that teach the basics in a pedagogical way that are free and accessible online. And you can even contribute back to them online. And it doesn't have to be, you know, there's a lot of ways of demonstrating experience. It doesn't have to be, you know, it's great if you have your own original research paper, but contributing, reading a research paper, implementing an example in some open source software, and contributing it back to the docs of that open source software, which doesn't take as much time as your own research. Like, that is an extremely great signal when we look at interns. So I think more than ever, things are a lot more accessible.
Yeah, if I may, I think probably the harder thing is trying to understand the organization itself. And I think that goes to Davide's point. And so one thing that I would encourage people to do is to try and find people who are in a company or a position where you would want to be in, and then maybe just reach out to them and maybe see if they have 15 minutes for a virtual coffee or something like that. You know, so that way you can get a better sense of what the organization is about, what research projects is doing, what that person is interested in, because it's always good to have people inside the organization who can act as advocates on your behalf when you're trying to submit an application or something like that.
And Anastasia, you've had a lot of experience outside of academia, and actually, Will mentioned the YouTube videos. I see that you have a very successful channel, and I recommend everyone to check it out. What's your take on like how to get experience even without an internship or before the internship?
Yeah, definitely. This is something that I actually made a video about. I think it was called like everything wrong with your PhD application, something like that. But research experience is very important. And I do recommend, going to these open source software and contributing to them. So when you go on GitHub, there's a label that you can select that says good first issue with a lot of these companies. And they're small projects that you can take on yourself and contribute back to the community. I also super recommend writing blog posts. So one of the unique things I think about me on this panel is I'm a PhD dropout. And somehow I'm still working in this field, and a lot of people think you need a PhD, and I think it's obviously super important. I got lucky, and one of the reasons I got lucky is because of this content that I kept creating in quantum computing, quantum cryptography, this whole space, and that allowed me to get these opportunities going forward. And for startups, I recommend, Travis mentioned reaching out to people. We often don't post these internship positions, but if someone emails us and says, here's my resume, if you have anything open, please contact us. We've taken on some people who have just reached out to us directly. I keep a folder of resumes just in case, we do open positions to reach out to people. And connect in the community. I really recommend getting involved in the community. I know there's a Qiskit Slack. I think there's some Circ communities as well. Just really get involved there and see how you can contribute, how you can collaborate with people working in the field.
Yes, and a bit going also like taking into account, since you mentioned also, Anastasia, like the importance of research, because this is a field that keeps evolving. I wanted to ask Davide, how would you advise students to seek positions in academia as well as industry for quantum computing or quantum technologies in general? I mean, it can be something simple, but what do you think are the most effective ways?
Yeah, I mean, so question is whether academia or industry as well, not only how I think, you know, we kind of answered this in a way. You need to show match as much as you can. That is a universal answer, and there is many ways to do this through personal connections and through also persistence and perseverance of following a specific target. Indeed, I mean, in the end, even choosing between academia and industry is the same question that you know, it's having a little bit of a vision of your future. And I mean, the great thing about starting after education is that you can afford a reasonable amount of mistake, a reasonable amount of changes, and the lessons learned are more than, you know, rewarding in terms of the possibility of you know, making something irreversible mistakes, which is almost never happens if you do good work. So the good thing about academia is it allows you a little bit to postpone a commitment towards a specific maybe, you know, approach of quantum information. I mean, if you're an academic researcher, you're working for the public, you know, interest. Same if you do for the government. So you're not, you know, part of a well-structured, you know, approach of industrial design. While in a sense, if you decide to join a company, in my opinion, I have a romantic view of that. You're not doing that because you're a mercenary, and you know, that's the best offer in the field. You're doing it, you know, just like, you know, joining a family and trying to really, you know, stick there. I mean, you should see that as potentially you know, your entire career. Okay, like there, it's you know, the next 20 years of your life. We will all retire early in our generation. Artificial intelligence will take over. So, so that's my advice, mostly deciding what to do, where to target. One thing is, I mean, the two, academia and the industry, are blended today in a way. So, especially many places allows you to publish and to be very transparent. So your contributions will be very visible to the next employer if you need to change. One thing is the mentors and collaborators, the senior people that you will be working with, are very important, in my opinion. I mean, you can't decide to join a group with a superstar professor that is never there, or she's never there. They will never, you know, maybe mentor you. And then, yeah, there will be, you know, a good reflection on your CV, but then you're on the hook on self working a lot by yourself. So, so that's a few words of advice I have.
And maybe there is a question from the audience by Miguel Angel Lopez Ruiz, which I think it's really in line with this discussion, which is academia more competitive than industry in the sense of landing a job, and how would that change in the near future? I wanted to first ask this to Anna, also because you went from like one of the most competitive, I think, programs at Harvard, went to quantum computing startup. So I wanted to, like, maybe you had a sense of what's the market right now, and what's how is it to what's more competitive in your opinion? What's hardest?
Yeah, competitive as in like landing a job in academia versus industry. Or
oh yeah, maybe you're right. Maybe that was the sense of the question. You're right. Maybe there is a double sense. I was also thinking what's most challenging, but yeah, probably also competitive for your career.
Yeah, so in terms of the job market, so I would think that landing a job in academia is just in terms of the number of available positions, it might be more competitive. But if we're talking about competitive in terms of the types of work we do in academia versus industry, I think it's kind of hard to compare because a lot of the companies that exist today, like Zapata, like IBM, Quantum, or Goldman Sachs, we all have pretty, I think, competitive internal research teams, which I think are quite highly academic in nature. It's just that you're in a different, I think, institution. So I'd say in terms of the quality of the work, I don't think I can really compare the competitiveness, but just to say, I think both sides are working on very interesting and difficult problems. Maybe companies have a more specific target that they have in mind, but I'd say in terms of the quality, there's, I'd say, not too much difference.
Maybe just to pick up on Hannah's point there, I think that one of the benefits of industry in a way, and which makes it slightly less competitive than academia, is that industry has a lot of adjacent things that they're also working on in the context of commercializing quantum computing or quantum technologies. Like, what does it mean to be a product manager or a program manager or a UX designer or something like that? And so if you're thinking long-term about your career and you happen to be interested in some highly technical thing like quantum, but you're also interested in some other, non-technical adjacent thing, I think there's lots of opportunities within industry to actually succeed there.
I think maybe I'll just say something like a little bit more controversial too. If the question is behind the question, I think I hear a little bit of the propaganda of academia, which is that like the best people stay in academia, and if you can't cut it in academia, then you go to industry, which is just like it's not true at all. The different kinds, first of all, the different kinds of jobs, and secondly, like all one needs, I think quantum computing and the quantum industry is a great counterexample against that. I mean, you just need to look at the folks and the quality of the research that they put out, over the last couple of decades. A lot of people who founded the field were in industry research groups like Bell Labs or at IBM, and even more today as more industry positions have grown. A lot of really, really great folks are in industry positions. So that's something that I remember when I was in grad school. You get that a lot in academia, but it's definitely not true at all.
Well, and I think industry has the unique, at least in the context of the team that I'm on at IBM Quantum, I mean, we partner with customers and clients, like Goldman Sachs, JP Morgan, et cetera. And so then, as Hannah said, our research is a little bit more focused, but still a lot of it is very foundational. Like, what does it mean to apply quantum computing to financial services is still an open question, right? And so there's lots of greenfield out there too, where you can make seminal contributions in terms of fundamental R&D by joining industry. So I do want to sort of echo Will's point that like you can go to industry and you can do great seminal work there too. It doesn't all just happen in academia.
And Anastasia, talking about the industry, what are you most excited about in this quantum industry, so-called quantum industry ecosystem? And what do you think, on the other hand, will be the main challenges in the next few years as we proceed with technology transfer?
Yeah, definitely. And this is actually a good transition from what we were talking about, because I also want to mention, sometimes we're solving different problems in academia versus industry. And the cool thing about it, and again, I've been in quantum now for 12 years now, so feeling old also on this. But what I noticed in the last 5-6 years as I moved from academia to industry was the fact that quantum physicists still didn't know how to really interact with industry. And I think that's changing, and that's really exciting to me, because when I was in the lab, I only worked with other physicists, and now industry, we're bringing in other people. A lot of these companies have so many other people, like Travis mentioned, software engineers and designers and product managers, and we're doing all that exciting work. And what we have to do, and why I'm really excited about content, is the fact that I would see this a lot, especially early on, people coming up to people in other fields and were like, give me a problem that I can solve on a quantum computer, right? But people from other fields don't have the intuition to understand which problems are able to be solved on a quantum computer. So there's this gap in how we could interact with people from other industries. So now as we're starting to bring in more people, we're starting to find that common language and how we're going to interact with people in other fields. So, I believe I saw another question pop up about that, about, there's not a lot of physics PhDs. I believe with quantum computing growing, you shouldn't have to need a PhD to be able to program a quantum computer or work with one, right? So our job as the physicists in the field is to be able to bridge that gap. And so that's what I'm really excited about in industry, is finding these applications, starting those conversations with people in finance and in material science and other technologies, and actually making this field useful to those people who will actually use this technology. And I think obviously that's going to be huge. And I really hope that, in the near future, we are going to be able to really start working on this commercialization curve and, bridging that gap, getting more people into it. I hope that it's kind of going to move more in the computer science direction, right? So if we look at history, physicists were the ones that created the computers and created this new field of computer scientists. What if we have this new field of quantum, programmers and things like that, we are all building up right now and helping those people get into the industry and actually be able to use this to solve their problems.
Thanks, Anastasia. Yeah, please, Travis.
You mentioned access, right? And one thing that I find the most interesting development is this whole notion of the quantum cloud, right? Like Will spent some of his time at Rigetti, right, standing up that quantum cloud there, right? There's quantum clouds at IBM Quantum and other companies, but I think we still haven't fully figured out what the heck does it mean to integrate quantum computing into a modern data center, especially as modern data centers themselves are evolving to be these very highly heterogeneous compute environments and stuff like that. And it's also exciting to think about how networking different quantum computers and building little quantum intranets will hopefully help lead developments in quantum computing more broadly, and also help us figure out what the heck it means to build a quantum internet, as it were, too.
Yeah, I love that whole, the quantum cloud is kind of a requirement right now for companies starting up, that once they create a product, the next step is to put their system in the cloud. One, because, in academia, sometimes there'd be a lot of claims and papers, and the reproducibility. I mean, we had this reproducibility crisis with Microsoft, on their on their paper 2 years ago that just was, not able to be reproduced. So now it's like, we have the technology, we have created this is what we claim, but now we put it in the cloud, anyone can go check whether, your results are correct, actually use that. And I think that's really important for the field to be taken seriously and move into commercialization. So yeah, I think that's perfect there. And your point on, I forgot your point, your second point.
That's okay. Well, it looked like you were going to say something. No.
We got lots of questions. Let's go.
My second, I don't know if you're asking me, Anastasia or Travis.
There are a lot of questions on the Q&A panel.
Oh.
Yeah, maybe we can ask some of them. I mean, I did try to ask some. Maybe this one is very interesting. In my opinion, is like from an anonymous attendee. It's now that governments start to pumping money into quantum technologies. I think they already have for quite some time now, but probably there's more coming. Will there be a shortage about qualified people starting their PhD? And maybe Davide, this is like also a question that maybe you can answer, because you are
starting their PhD. Yeah, I'm not sure about. I mean, the narrative is, I'm not sure. I'm not following really the statistics of how many people are doing the PhD. I mean, but definitely there is. I think it was posted by Jared of Google that there are more than 250 companies hiring, with more than 750 job posting active on, LinkedIn, Indeed, all these sorts of things. So that's certainly an order of magnitude larger than the offering in the United States in terms of people that with a documented experience that have just finished their PhD and they're ready to become a practitioner in quantum computing. So I believe that for the next few years, that will be a very, very fertile, job market, and then it will probably plateau. But no, I believe that at the PhD entrance level, one thing I would like maybe to say is that there's not only the United States, especially for the education. I would say that PhD programs, they should be seen across the planet. My opinion, you don't have necessarily to have a PhD from a top tier US institution to get what the PhD gives you, which is the opportunity to focus, the excuse to be obsessed for a significant long period of time in something that you deeply care about, and to show to the world you can do that. You can become an expert over a short period of time in something and push the frontier of knowledge in that. And that you can do it more or less everywhere.
I think also governments are funding initiatives, not just at kind of the PhD level, right? I think the NSF has the Q12, initiative of trying to teach high schoolers some of these concepts. And I was just listening to a talk yesterday at a panel or something like that. And like, I don't necessarily, and the speaker said something really interesting, which was we don't necessarily need to create whole new curricula all the time, though new curricula are probably going to be helpful. I said, if we can just figure out how to augment existing curricula to teach people the skills which are sufficiently adjacent to quantum computing and quantum technologies, that by the time they do kind of a standard degree, they will already be ready to participate in the quantum workforce in some way. So I don't think there's going to be a shortage per se in that sense.
So I will ask Anna one question from Mustafa Tony that is in line with this discussion, which is how do members of the quantum computing community collaborate together while the field is very multidisciplinary in its nature, intersecting math, physics, computer science, and technology and engineering. And I wanted to ask you, Anna, because you're obtaining a degree in chemical physics, and there's the chemistry part that maybe a few years ago would not be, the standard curriculum for someone in the quantum computing space. So yeah, if you could tell more about your experience in this kind of like interaction, both maybe during your research in academia and internship.
Yeah, so in terms of collaborating with people from different backgrounds, I think because there's so much to explore within the quantum computing research field, it's, I think, in some sense, inevitable that you're going to work with folks from with expertise from different fields. Just from my own experience, for example, so I come from a more a chemical background. So when I was starting my PhD and working on quantum computing research, I first learned about, for example, the variational quantum eigensolver algorithm, or the VQ algorithm, to estimate ground state energies of molecules. But over time, I realized that a lot of these near-term algorithms, regardless of if it's used for chemical applications or, for example, QAOA, or more recently, quantum machine learning algorithms, a lot of these algorithms have a very common structure to it. And so one of the main questions I had was, for example, so in these algorithms, they use something called a parameterized quantum circuit, or a variational circuit. And one big question I had was, well, how do I quantify the capabilities of these circuits? And in order to ask these questions, I wanted to use, for example, tools from applied math or just mathematical physics, but I didn't have that background. So I actually ended up talking to one of my colleagues in the research group that I was in, Peter Johnson, now a founder at Zapata Computing, because I knew that he was a mathematical physicist. and he had the kind of the language and the tool set or the skill sets to help me answer this question. So we ended up working together in order to say, so I had more of an experience with working with the VQ algorithm, but he had the background, mathematical background, so that we can correctly kind of frame the question and come up with several different ways to quantify basically the performance of these circuits. So likewise, there are just many different problems in quantum computing where in order to, for example, formulate the problem and tackle the question, I think people from various different backgrounds, it's almost the quality of your research projects will improve the more kind of different perspectives you have from different people from with different expertise. So I think just to say, I think it's quite easy to collaborate with people from different fields on something like quantum computing.
I'd also like to hop in and say that the great thing about industry is we do have all these collaborating different backgrounds. And the best part about that is it kind of gives you more freedom to ask questions. And as someone that's hiring, my biggest red flag when I'm hiring is someone who's not able to admit that they don't know something and won't ask the question, because to me, that's tough, right? Like, I want you to ask questions. I want you to collaborate. Let me know what you don't know so I can help you so we can move forward. And so because we're all multidisciplinary, ask questions. We all have different backgrounds. You came from a different background. You're maybe studying more theory work or more experimental, or you just haven't covered a course some people have. It's okay. Ask those questions. So what we actually do pre-COVID, we would do this every Friday. We'd order lunch and do takeout and do what we called learning cafe. And people from, different backgrounds would present. So we'd present, Quantum 101 to the electrical engineers, the mechanical engineers. We do a walkthrough of software design for, people who hadn't programmed the software, and that's totally okay. So I know this is definitely a very academic thing, and it took me a while myself to break out of it, but asking questions does not make you stupid. It actually will help you accelerate your learning and move forward faster. And that's what we look for in industry.
Nathan, I just wanted to jump in and say we have about 5 minutes left, and there was a particular question in the Q&A which I wanted to plug. So in line with the DEI panel, yesterday we have a question: what is industry doing to ensure decent working conditions, in particular for addressing diversity, equity, and inclusion problems? I don't think Will has spoken in a while. Will, do you want to say a few words about this one?
Sure. Yeah. I mean, I think there's, broadly, quantum information is not the only place where this concern comes up. It matters in all sorts of different industries. There's a few things that are exciting in our own community that industry has supported in different ways. So an example is the Unitary Fund. So we provide no strings attached grants to help people do projects that can demonstrate their experience, without needing to come from some particular credential background or kind of the usual feeder directions. And that's been supported by lots of folks in the quantum industry. Google X, IBM, Microsoft, Xanadu, Zapata, Rigetti. I'm gonna get in trouble if I don't name everybody now. Strange Works. Like the point is, there's a pretty broad, for a new industry, I'm kind of emboldened that there's an understanding that we have the chance to do a little bit better at the beginning of the quantum computing industry, maybe a lot more than a little bit, a lot better than adjacent STEM niches. And so there's other initiatives out there, like so there's a lot of the educational initiatives, like for example Qubit by Qubit, which has one of the Unitary Fund projects with them recently was they host these, they have a high school course right now on quantum information, future PhD students, that they have about 5,000 students in online today for this year. And they're taking those workshops and little bits of that curriculum, and they're targeting different kind of STEM deserts, different communities in the US to start that don't typically have access to great STEM programs. And they're showing them, what's a little bit about what's happening in this world of quantum, and hopefully that will inspire some folks to then, pursue this path. And and we'll end up with a much more equitable and diverse industry. So that I don't. It's a big question, but one thing that I'm emboldened by is that everybody in the academic, but also in the corporate settings, is paying attention to it.
I would say that at IBM Quantum, we've baked these ideas into how we've been doing our hiring for both kind of the staff positions as also for the internship positions. I think we recognize that, for example, the Qiskit community, which spans the entire globe, is a very diverse one. And therefore, we should be providing opportunities to that community in its full range of diversity.
Yeah, and very briefly, I pasted here the links of qturn.org and YQCA.dev, which are two organizations active in diversity and inclusion in the quantum computing community. So our time is up. It flew. It was very fast. I pasted here the Twitter handles of all the panelists and Ryan. So thanks again for attending, and hopefully maybe we will be able to answer a couple more questions meanwhile in writing. I'll leave it to Ryan. And thank you all to the panelists and to all the attendees.